Okay, today we're going to be talking about the 3D printed project from the Devil Girl from Mars, her robot, which I guess is pronounced Chani. I don't know. Looks like Chani or Chani to me, but Chani, maybe a Native American from Mars. At any rate, I'm not going to go through all the parts that I've printed yet because I actually haven't even tested some of them. But I wanted to go through the mechanical part of the build. So if you guys decide to build one of these later, you'll be able to do so. So this is the frame piece, the main frame. This is going to slide up inside the body. You can see I have my TT motor. It slides in before the battery pack is in. Slide it in. You can drop in a couple of 632 screws to hold it in place. You can put them on this side too if you want. And then I have the battery pack, and in my case I took the negative lead from the battery pack before I glued the pack in. It slides in this way. Imagine that being slid out where you can get to the motor. I soldered the negative lead to one side of the motor. I took this it's actually servo wire, but you can buy servo extension cables, or you can just buy this wire in bulk. It's really inexpensive. But I wanted to keep the three wires grouped together. So I got the white one soldered to the other side of the motor. Then the red wire I just soldered to the red wire off the battery pack. That way if I connect the red and white together through the little slide switch, it'll turn the motor on. Then I also brought the black wire, which I told you I soldered to one side of the motor from the battery pack. I brought it up as well, because I need to be able to get a switched voltage to the lights that are going to be up in the top head of the robot. So that's what's going on here. Then there are two cam pieces. As you can see, they fit on. You want to make sure you put them in opposite directions on either side so you can get proper walking action here. So something like that. One lobe is up, one lobe should be down. And make sure those turn freely without hanging up. Good. In this case on the TT motor, I used the 220, or 220 to 1 is how we would say it, gear ratio motor, which I found up on AliExpress. I suppose if you can find the 1x120, which used to be my old favorite, maybe you don't want to go with the 3 battery pack. Maybe you don't want the thing walking super fast. Maybe you want to go with just 2 batteries. The reason I went with the 3 battery pack and then the slower motor was that I wanted to make sure I had enough voltage for whatever LEDs I put up in the top head of this thing without having to use a boost circuit to get them to light up. Okay, the legs, these pieces, both left and right leg are the same file, so you just print 2 of those. And on the inside, this piece, I left it a different color so you could see that it was separate from that. This piece is symmetrical also. You can see you can turn this one way or the other depending on whether you're doing a left leg or a right leg. And in that little hole, I'm using paper clips for axles. So you just take your paper clips and run them through, there we go, run them through the little holes to pin in the wheels and pin in the little ratchet arm. See that little ratchet arm up in there? Do I need to turn on this light? Let's see. Come on, light. There we go. Yeah, now you can see that little ratchet arm up in there. And then, of course, the ratchet wheels. Only ratchet in the front, so it doesn't really matter in the rear, because there is a left and a right on these ratchet wheels, which will matter. Putting a rubber O-ring on there for traction. The inside diameter of where that O-ring goes is about 7.2 millimeters, if that helps you find something. I just buy O-ring kits from Harbor Freight. The whole kit's just got hundreds and hundreds of O-rings in different sizes, and find ones that snap on. You'll want to make sure that the hole in the wheel spins freely on the paper clip. If it doesn't, run a little teeny drill bit through there and clean it out until it does. You don't want any drag on that at all. And of course the one on the front, this would be the front of the foot. This is going to go in towards the body. Needs to turn freely if the foot was moving forward, but then lock if it's going backwards, and it'll only work from gravity if it's sitting there. You hold it like this, of course, the ratchet's going to drop away. But that little ratchet drops down and then grabs. So that's why there's a left and a right one, so that you can take the one for the other foot that you build, flip that holder piece that we just talked about around, put the same little ratchet arm, there's only one ratchet arm in there, you put paper clip, and that way by using the other one you can keep the rubber O-rings facing towards the outside of the feet. And of course you got to have the angle, if it'll focus. You can see on the foot there, you got to have that angle of those little prawls facing the right way, so that when they turn this way they can lift that ratchet arm out of the way, and when they are forced to go back they lock. So that's the secret to that. Now, to hold these legs onto this part, you're going to need to cut some 3mm rod. This is about 40 millimeters long, and they're going to pass through these holes and pin these things in place. Now the duck bill, that's the back of the robot, so this would be the front. So this leg is going to go on this side, just over the cam like so. I'm assuming this is in camera because I can't look at what I'm doing here and stare at the view screen on the camera. So I'm hoping. There we go. In the end, when I do the final assembly, I'll probably put a little drop of E6000 or something on the end of that, just to keep that rod from working its way out. It can't work its way out once it's slid into the body, but every time I want to change batteries, you slide this whole thing out of the body, and you don't want the rod dropping out every time and having to put it back in place. So put the top rod in, and let's get the bottom rod like so. So now you can see I've got one leg attached. I'll go ahead and turn the motor on so you can see how that cam is going to make the leg move forward and backward. And then of course you just do the same thing for the other side. There on. Yeah, from the pictures and the movie, it's hard to tell whether the robot was painted in a matte flat silver or whether it was a matte flat white. So I decided just to print this in white because I can't really spray paint effectively this time of year. It's not even going to warm up to freezing in my location, and I can't spray paint in the house obviously. So there, roughly speaking. Let's get that, let's get the switch. And there it is, marching along. Okay, and as you can see, the reason that this wire is so long is because once it pulls up out of the body, you got to have this clear in order to be able to get in here to change the batteries and everything. And I'm going to cover those aspects of the build in the next video. Let's get that sitting there.